For hundreds of years, thousands of years, humans have thought the universe is a very static place. If you go out at night and look into the night sky, you will see that things don't really change much. The universe appeared very static for a long time. We now know this is not true. The universe is a highly dynamic place, and things are happening all the time. Every single second, a star explodes in a gigantic supernova explosion somewhere in the universe. And we have to go and find it. We have to build instruments that are capable of finding those unforeseen events.
Way back in 1998, we were at a scientific meeting in Boulder, Colorado, and I was invited to invitation-only meeting. And at that meeting, 6 of us got together and we came up with the idea of creating SWIFT. It was a group of people from Goddard and from Penn State.
SWIFT set out to combine gamma-ray instruments that could roughly find out where the gamma rays may be coming from, but only with a very crude estimate. And then, through the design of this remarkable spacecraft, to spin that spacecraft rapidly across the sky and point an X-ray telescope and an optical ultraviolet telescope at the possible location of the gamma-ray burst.
Whenever a gamma-ray burst goes off, which happens about twice a week, the satellite detects the gamma-ray burst and it sends a message down to the ground. And it goes out on a network to our cell phones and we're paged.
What I love being a member of SWIFT team is carrying a BlackBerry on the side of my hip that became almost like a part of my body. And every time SWIFT discovered something unforeseen or a gamma-ray burst went off, the BlackBerry would start vibrating and I would run to the nearest computer as fast as I could. And this is something I miss now, not working anymore for SWIFT, this excitement that things can happen at any time and you don't know what it is.
I have on 2 occasions gotten a gamma-ray burst alert while I was giving a lecture about SWIFT. And so I told the audience that here's a new gamma-ray burst coming in. And we actually one time got it on the screen and watched the data as they were coming in front of the audience.
I was woken up by GRB 090423. It was 4 in the morning. It was really annoying. It was 5 years into the mission, so GRBs were not so new and exciting then. And I was like, oh yeah, yet another GRB. Dealt with it, went back to sleep, woke up the next morning, and there was information from ground-based telescopes that had observed this gamma-ray burst in the infrared that were implying that it was a very distant gamma-ray burst at redshift greater than 8. That was very exciting. And the next night, telescopes in Hawaii were able to confirm that redshift, that it's at a redshift of Z of 8.2. That means that gamma-ray burst went off more than 13 billion years ago. It's 13 billion light years away. We're seeing light from a star that was only 700 million years after the Big Bang. That's one of the most distant objects that's ever been detected. That was very cool.
In my case, I had a different experience where it was Thanksgiving and my family and I had spent a large amount of time working to prepare the Thanksgiving dinner. We had friends round and everything was ready, the food was on the table, and right as I put my fork into my turkey, my phone went off, something had exploded in the universe, SWIFT had detected it, and we had to go to work. So it doesn't always happen at convenient times, but it is still exciting.
Basically, I'm on call 24 hours a day, so it's hard to decide where my personal life starts and where my SWIFT professional life ends.
As the astronomy and astrophysics community has engaged with SWIFT, the scientists have learned new ways to use the observatory, and its ability to rapidly follow up new sources has been seen as a really incredibly useful tool. And so SWIFT has evolved from spending most of its time observing gamma-ray bursts and following them for sometimes weeks or months afterwards to doing more science that's proposed by the community to study other types of objects.
We look at supernovae, novae, black hole transients, comets, flaring stars, all different kinds of objects.
Basically, every year, SWIFT makes a new discovery that changes some field of astrophysics. We have made many, many discoveries in other areas. We've discovered something called a tidal disruption event. That's when a star is falling into a black hole and gets ripped to shreds, and we see the light from that collapse onto the black hole. That's very, very exciting. We've made important discoveries about comets, how much water and how much other material there is in comets that people didn't know before. We have actually seen a supernova, a star that blows up at the moment when the light broke out from the surface of the exploding star. Every year for the 10 years of SWIFT, we've had one of these really important discoveries.
It is the Cadillac of satellites. It does everything in the transient field. In one package, and mind you, this is a small package, it's an Explorer mission, we have a huge amount of capability.
SWIFT's ability to observe many objects in one day, I think, is what makes it special, as well as its ability to respond very quickly to new events in the universe. No other mission is as agile as we are.
SWIFT performs every day 5 to 7 targets of opportunities, or sources that are requested by the astronomers to be observed. And they are observed every day, and this is a very powerful capability that the community now is taking advantage of.
I knew the instrument, I knew its capabilities, but I've been extremely impressed with the team of people that behind the scenes make the mission work. There is a group of duty scientists, mission planners, the flight operations team that make sure that we can continue to observe as many targets as we do, that we can continue to do the rapid response that is really unique to the observatory. And without such a dedicated crew of people behind the scenes, I don't think SWIFT would be nearly as successful as it has been.
SWIFT mission has been extremely successful in the past up to now, and it will no doubt continue to be successful in the future. And I am sure that a lot of serendipitous science is just waiting for us.
The universe has a lot of secrets that have not been revealed yet. We do believe that SWIFT can and will reveal many more mysteries and puzzles in the universe.
We don't know what will happen over the next 10 years, hoping that SWIFT will still give us exciting data. But what we do know is that SWIFT will give us exciting new data because of its pure nature. This is what it was built for, to study new, unforeseen, unexpected events. And they will inevitably happen.
It's been a part of my life every day for the last 20 years. I love it. It's produced so much great science, and it's been very fulfilling. But every day I think about this delicate instrumentation in the harsh environment orbiting the Earth and how it's able to keep going all of those years. And I very often will just look up at the sky and think about SWIFT. It's true.